So let's go to MCQs. These are also good questions. Area bounded by this curve. This is a cubic function with x-axis and between x equals to -1 and x equals to 1, from -1 to 1. Okay. So do you know what's the graph of this? It's again a standard curve, remember. It's a very well-known standard curve, cubic function here. Okay. You take 2-3 points, you will realize. See here, if I take origin, 0, 0. If I take 1, it is 1. If I take 2, it is 8, and so on. If I take -1, here it is -1. -2, -8, remember. So it would look like this. This is just rough graph of fx equals to function y equals to x cube for your information. From where it starts here, x equals to -1, where it ends over here, right? So you can see that this is the area here, either this portion or this portion. Fine, this is the required region. You want the area of this the shaded region. Oh sorry, here you have -2, I'm sorry. So this is -2. Anyway, diagram remains same more or less. Okay. So how will get the area? You can use simply the formula here. Area equals to modulus I. Okay, and what about I there? Where I is given by integral from where to where? -2 to 1 y dx. You are doing around x-axis, remember. So -2 to 1, what is y? X cube. Integrate it. So x raised to 4 upon 4. Limits are from -2 to 1. Put upper limit, so 1 by 4. Minus, this is nothing but here 2 raised to 4, 16 by 4. So we'll get the -15 by 4. That's I. But you know that area is always positive. So therefore here A equals to 15 by 4. Which is which option? C. Area never be negative, you know. Now here one question might be there in your mind. Earlier I had explained. See, some portion is in one half planes, the other portion is the other half plane. So why I have not considered two integrals? Actually you should consider -2 to 0 and then 0 to 1 and then you add them, right? Or you could have done like this also, remember. You should have habit of doing like this when areas are in two different half planes. I equals to modulus I1 plus modulus I2, where what is I1? -2 to 0 bounded by x cube plus 0 to 1, 0 to 1 bounded by again x cube, and you can simplify, you will get the same answer. But why I did here is a single integral? Because you see function never take the turn, it goes up, then you can do like this. But if function has taken the turn like this, first is going up and then it comes down, then you cannot do like this, remember, like sine function question. See, first it was going up and then it comes down. Then you cannot do as a single integral, you need to do like this. Even in this question, if you would have done like this, obviously answer is right, remember. Question number 17. The curve is given by y equals to x into modulus x. Between which two ordinates? Between here x equals to -1 and x equals to 1. Fine. Now here you have negative and positive. So if x is positive, then modulus x become x. So this is x squared if x is positive. And if it is negative, then this is -x squared, you know it. So this is -x squared if x is negative or 0, kuch bhi rakho, 0 then 0 actually. So here There is a combination of two parabolas. Y is equal to x square. If x is positive, then it's a parabola, you know, right? So let me draw that. So this is the x-axis here. Let's consider this as the y-axis. So if x is positive, in this portion it would be parabola like this. This is y is equal to x squared. Now if x is negative, that is in this portion, again it is a parabola, but it is in the down direction because of this. So it would be like this, remember. This is y equals to minus x squared. The mirror image of this portion. Fine. From where to where? From x equals to minus 1 and here x equals to 1. So it's like previous question only, remember. So either this portion or this portion, remember. So what is area? That's modulus of I, where I is given by from where to where? Minus 1 to 1 y dx. Now actually this is I1 plus I2 you need to do. How will do this? Minus 1 to 0. So this where x is negative, so you have minus x squared dx. And then you have 0 to 1, so positive, so you have x squared dx. You know all these things. Just integrate it and simplify. You will get 2 by 3, right? And therefore area equals to again 2 by 3. I wrote directly here. 2 by 3 is which option? That's option C, remember. Just simplify and check whether it is 2 by 3 or not. Okay. Next question, 18th, which is also a very nice question. Let's do that. Question number 18. Area of the circle. You are given one circle here. X square plus y square equals to 16. Circle with center 0, 0 and the radius equals to, 4. This is a very standard circle. Okay. Exterior to the parabola. Right. Exterior to the parabola. Which parabola? You are given symmetric about which axis? Symmetric about x-axis and through origin. So let me draw the diagram and let's see which region you are asked here. So here for these two coordinate axes, circle, center origin, radius equals to 4. So circle would be like this. X-axis, y-axis. And the parabola is symmetric about x-axis. So parabola would be like this. Parabola would look like this. Okay. Now, what is asked in the question? Area of the circle exterior to the parabola. So you are asked this portion, remember. You are not asked area between two curves. आपको ये portion चाहिए. This is the question. You want this, right? So how we'll do this? As we did earlier, first we get the area of this portion and then that we subtract from the area of the circle. Area of the circle, pi r square. So we find the area of this dotted region. It's area between these two, and this area should be subtracted from this, remember. Okay, now here x equals to 0. Radius is 4, so here x equals to 4, that 16, so radius is 4. We need to get this intersection point. क्यों? Because A जो region है यहाँ तक up to this, that is bounded by parabola. If you remember, before few minutes we did such question. So up to this portion it is bounded by parabola, then bounded by circle. We add this two and we make it double, and then we subtract from the area of the circle. Okay, so first we get the area between these two, remember. So let me get these intersection points first. So solving the equations, we want x, so we make it we eliminate y from there. So 6x equals to 16. just putting the value of y square, which is 6x. So x square plus 6x minus 16 equals to 0. Factorize this. What are the factors here? You know, factors are 8 and 2. That's quite obvious. So take x square is there. Take x common, so x plus 8. Take minus 2 common, so x plus 8 again. So x minus 2 into x plus 8 equals to 0. So either x equals to 2 or x equals to minus 8, but this is the required value. We don't want this, right? This is not our required value. The required value is this. So here limit is x equals to 2. So 0 to 2 bounded by this parabola, 2 to 4 bounded by this. We get this. We make it double, so we'll get this, and then we'll subtract from the total. Fine? Okay. This is, I suppose, same as question number, which one? Question number 15. This getting area is just question number 15, right? We did it. That was also parabola and, you know, circle. Okay. So required area A equals to area of circle pi r square. R is how much? 4. So pi 4 square minus area between these two. Area between the circle and parabola. Okay, so this is just how much? 16 pi minus, let me call this as I or modulus I. We call this as equation number 1. We get I and we place here and we'll simplify. Okay, I'm sure you can do it. Let me see here. So now we go to I, where I, you know, it is 2 times area in the first quadrant. Area in the first quadrant. That, you know, we did it before few minutes, question number 15. So 2 times integral from where to where? You know, 0 to 2. Why this? You know, bounded by parabola. Y dx, here y is a parabola. From where to where now? 2 to 4. Bounded by what? Circle. Y dx. I hope this is clear to you, because now we had number of such question. 0 to 2 bounded by parabola. 2 to 4 bounded by this. तो आपको इतना portion मिलेगा, remember. And we'll make it double. That's why I wrote 2 here. And then we'll place here. तो आपको ये जो green shaded region है, वो area मिल जाएगा. Because question में exterior region बोला है, remember. Okay. So here 2 times integral 0 to 2. What is y? Y is a parabola. Parabola में से y निकालो. It will be root 6 root x dx, remember. Plus 2 to 4, and circle में से y निकालो. What is that? That is nothing but the 16 minus x square, you know, dx. Fine. Now we just integrate. This is now simple question of definite integral, remember. Okay, so I'm doing that. Here 2 times root 6 as it is. What is this? X raised to 3 by 2 upon 3 by 2. And limits are from where to where? 0 to 2. Raise the power by 1. Okay? Fine. Then, what about the other one? How will integrate the other one? That also you know, because we did it number of times now. X by 2 into the same expression. 16 minus x square, always plus a square by 2 into sine inverse x by a, that is x by, remember this is 4 square, so a is 4, don't write 16 here. And limits are from where to where here? Limits are from 2 to 4, remember. 2 is common for both, remember. So it's like this, remember. 2 is common for both. So we just simplify this, okay? So I'm just placing the limits here, 2 as it is, here this is 2 root 6 by 3. Here you know 2 raised to 3 by 2 means root 2 3 times, which is 2 root 2. If you put lower limit, it will be just 0. So here minus 0, which I am not writing. Come to this plus. Now first upper limit. So let's put upper limit first. So if I put 4 here, this is 0. This would be 8. Sine inverse 1, which is, you know, here pi by 2. This is upper limit minus. Here now I'm putting lower limit, so I'm writing inside the bracket, remember, 2. So this is 1. This is root 16 minus 2 square, which is 4, so 12. So it is you know 2 root 3 here, plus put here 2, so this is here 8. And this is sine inverse. If I put 2, sine inverse 1 by 2, which is pi by 6. Fine. Okay. Now simple algebra. 2 as it is. What is this? This is nothing but here 2 into 2, 4. This is root 12, which is 2 root 3. So this is 8 root 3 by 3 plus 4 pi minus 2 root 3 minus, what is this, 4 pi by 3. Fine. So here if you combine these two, this one and this one, root 3 terms, here 2 as it is, 6. So it will be 2 root 3, 8 minus 6, 2 root 3 by 3 plus, we combine these two, so 4 3 are 12 minus 4, so it is 8 pi by 3. You can find 2 common from there, so I'm just taking 2 common. Let me take 2 common here. So outside you will get 4 here. So if I take 2 common, what will get inside the bracket? Even by 3 also you can take common, so 4 by 3, this is root 3 plus 4 pi. Right. This is I, remember, and therefore by 1 the required area equals to 16 pi minus 4 by 3 root 3 plus 4 pi. And if you want, you can take 4 by 3 common here. So what will get here? 4 will come out. So here you are left with I suppose 12 pi, check, minus root 3 minus 4 pi. So 4 by 3, this is 12 pi minus 4 pi. So this is 8 pi minus root 3. 8 pi minus root 3, and this is nothing but the option C, remember. 8 pi minus root 3, 12 minus 4. Right. So even though it is MCQ, still you see that it's very good question. Okay, question number 19, last MCQ here. So there you are asked area by bounded by the y-axis, y equals to cos x, y equals to sin x from 0 to pi by 2, remember. Okay, so let me draw the graph here. You will realize which area you are asked. So with these two coordinate axes, this is 0, here pi by 2, let's take pi. So sine 0, 0, sine pi by 2, you know 1, and then sine pi 0 here. Okay, here somewhere you have pi by 4. Cosine graph, you know cos 0 is 1, so it starts from here. What's the graph of cosine function? At pi by 4 it would cross this. At pi by 2 it is 0, so it would be like this. Now you are asked the area between this and y-axis, so you want this ratio, remember. Okay, you need this much. Right. Now x is 0 here. You know, common point is always pi by 4. At pi by 4 both are equal, so here x equals to pi by 4. So this minus this, so here area equals to modulus of I, where I is given by integral from where to where? 0 to pi by 4, you know, fx minus gx, the whole dx. Area between two curves I am doing, remember. Now 0 to pi by 4, fx means any one of these two functions, right? You can write any one of these two, cos x minus sin x. Even if you have written sin x minus cos x, that's not important because you are going to write the modulus. So just integrate this, write upper minus lower, right? And place the value of I here. You will see that you will get a equals to root 2 minus 1. This is nothing but option B. Okay, that's nothing but the option B, root 2 minus 1. This is very simple integral. You know, integral of cos, you know it, it is nothing but here. If I do it here for you, integral of cos, it's a sin x minus integral of sine, you know it is cos minus cosine, so plus cosine x. Limits from where to where? 0 to pi by 4. Put upper limit, sin pi by 4, 1 by root 2, 1 by root 2. So it is 2 by root 2 minus lower limit. This is 0, this is 1. So you are getting root 2 minus 1. This is I, remember. And therefore A equals to root 2 minus 1. Fine. Now here in this question, suppose if you are asked area from 0 to pi by 2, for example, up to this, let me show it in the next one, like here 0, here let me write pi by 4, and here pi by 2. There is a graph of sine function, sine pi by 2 is 1. There is a graph of cosine function. At pi by 4 it would cut this. Now area between these two, so A hoga, this one and this one. So how will integrate 0 to pi by 4? Fx minus gx plus pi by 4 to pi by 2, remember. This area I am talking, this much. Right. Now this area is always root 2 minus 1. Or AB same hoga. This is also root 2 minus 1, remember. So the double, that is twice root 2 minus 1. Right, that's area. If you are asked area between these two functions, remember I am talking between sin x and cos x. Area between sin x and cos x. ये जो shaded portion में मैंने आपको बताया वो, ये portion always root 2 minus 1 होगा. ये दोनों symmetric है, ये भी root 2 minus 1 होगा. आप integrate करके देखो using fx minus gx concept. So we'll get the double of root 2 minus 1.